Here's problem number 8, sample test. A 12 kilogram block on a horizontal frictionless surface is attached to a light spring, force constant 0.8 kilonewtons per meter. The block is initially at rest at equilibrium position when a force, magnitude P equal to 80 newtons, acting parallel to the surface is applied to the block, as shown. What is the speed of the block when it is 13 centimeters from its equilibrium position? Okay. Well, we have a spring, force constant 800 newtons per meter. We have a mass of 12 kilograms. And we have a P force over here of 80 newtons. It's going to act on it over a distance of 13 centimeters, 0.13 meters. So at some later time the block's going to be over here, moving with some final velocity v sub b, because we're going to call our final position B and our initial position A. So kinetic energy at A plus potential energy at A plus any work done along the way will equal kinetic energy at B plus potential energy at B. One equation to rule them all. In this case, we started from rest, so our kinetic energy at A is 0. We're on a level plane, and the spring was not compressed or stretched at point A, so our potential energy at A is 0. However, at B, we are going to stretch the spring, so we'll have a 1/2 kx squared for that, even though we're still on a gravitational potential level of 0. So we just have to worry about that. Work done along the way. Well, work along the way is going to equal P times D cosine 0 degrees. Cosine of 0 is going to be 1, so it's just going to be P times D, positive. We're adding energy along the way by applying this force. So that's what's going to go in there. And of course kinetic energy is 1/2 mv squared. So putting all this together, we now have that the work along the way, P times D, is equal to 1/2 mass times the velocity at point B squared plus 1/2 kx squared. Solve this for the velocity at point B. So we have 1/2 the mass times the velocity at B squared is equal to PD minus 1/2 kx squared. Multiply both sides by 2, divide by mass, take the square root, and now I have that the velocity at B is equal to 2P times D minus kx squared divided by the mass, square root. So that is equal to 2 times 80 newtons times D, which is be 0.13 meters, minus 800 times 0.13 for x squared over the mass, which is 12 kilograms, all this square root. So if we calculate that, 2 times 80 times 0.13 minus 800 times 0.13 squared, all that divided by 12, which is 0.6066, square root of that, I get 0.779 meters per second. So the speed of the block when it's 13 centimeters from the equilibrium position is 0.779 meters per second. Answer.